Imagine this, a pressure vessel operating at -40 degrees Celsius. A weld that looks perfect on the surface. But deep inside that steel, a tiny crack. And at that temperature, if the material is brittle, that crack doesn't stop. It propagates, instantly, catastrophically. That is exactly why ASME Section 8 Division 1 Paragraph UG-84 exists. It mandates Charpy V-notch impact testing, to make sure your material and your welds are tough enough to survive low-temperature service without brittle fracture. Welcome to Weld Fab World, welding till the end. I'm your host, and today we are doing a complete, code-accurate walkthrough of UG-84, Charpy impact test requirements, straight from the ASME BPVC Section 8 Division 1, 2025 edition. By the end of this video you will know, when impact testing is required, the exact specimen dimensions the code demands, how to determine test temperature relative to MDMT, what the acceptance criteria numbers are, and what happens when your welds need impact testing too. This is the one video on UG-84 you will bookmark. Before we open the code, let's understand why this test exists. Steel is not always tough. At elevated temperatures, steel is ductile, it bends, it deforms, it absorbs energy before it breaks. But at low temperatures, especially below what we call the ductile to brittle transition temperature, the same steel can fracture with almost zero warning and almost zero energy. This graph, the energy transition curve, is the entire reason the Charpy test exists. The Charpy V-notch test measures exactly this absorbed energy. A pendulum hammer strikes a notched specimen. The energy it absorbs before breaking tells us whether the material is safe at that temperature. The notch is critical. It creates a stress concentration, simulating real-world defects, weld toes, and geometric discontinuities. This is not just a lab exercise. It directly maps to your pressure vessel's real service conditions. That's the physics. Now let's open UG-84 and see what ASME actually requires. Host UG-84.1, the general paragraph, tells us this. Charpy V-notch impact testing of weldments and vessel parts subject to stress due to pressure shall be performed in accordance with the provisions of this paragraph when required by the rules in subsection C or subsection D, so it is conditionally mandatory. The trigger is in subsection C for carbon and low alloy steels, and subsection D for high alloy and heat-treated steels. Here's the most important practical point, and many engineers miss this. Per UG-20F, impact testing is not mandatory if your MDMT is warmer than -20 degrees Fahrenheit. That's -29 degrees Celsius. And your material qualifies under the exemption curves of UCS-66. But the moment your MDMT drops below that, or your material doesn't meet the UCS-66 exemption, UG-84 kicks in and impact testing becomes mandatory. Think of UCS-66 as your get-out clause. Think of UG-84 as what happens when that clause fails. UG-84.2 paragraph A tells us how the test shall be conducted. Test procedures and apparatus shall conform to the applicable paragraphs of SAW 370. That is the standard test method for mechanical testing of steel products. OR ISO 148 parts 1, 2, and 3. Both are acceptable under the 2025 edition. Now, when no procedural impact testing requirements are given in the material specification, you go to table UG-84.2-1. This table tells you which specification applies to each product form. Plates for UCS and UHT follow SAW 20S5. Pipes follow SA 333. Forgings follow SAW 350. Castings go to SA 352. Know this table. It comes up in audits constantly. A quick note on small parts. UG-84.2, C, a lot of up to 20 duplicate small cast or forged parts can be certified by testing one set of specimens from a single randomly selected part of the same heat and heat treatment condition. And for small vessels under U1, J, a lot of up to 100 vessels can be covered by one set from a single vessel of the same heat and furnace batch. UG-84.3 governs the test specimens. And this section has more detail than most people realize. Rule number 1. Each set of impact test specimens shall consist of 3 specimens removed from each area required to be tested. Always 3, not 2, not 1, 3. These specimens shall be the Charpy V notch type, conforming to Figure UG-84.2-1. The full-size standard specimen is 0.394 inches by 0.394 inches. That is 10 mm by 10 mm, with an overall length of 55 mm. The V notch is at 45 degrees, with a root radius of 0.25 mm. Now, and this is critical, full-size 10 by 10 specimens apply only when nominal material thickness is 7/16 inch, 11 mm, or greater. For thinner material, you use the largest obtainable subsize specimen. There's one more special case, UG-84.3 If your material absorbs more than 180 foot-pounds, 244 joules, on full-size specimens, you are allowed to use a 10 by 6.7 mm subsize specimen. And in that case, the acceptance criteria change, you need 75 foot-pounds per specimen minimum. We will come back to that when we cover acceptance criteria. Important cutoff. If the maximum obtainable specimen width along the notch is less than 0.099 inches to 2.5 mm, no impact testing is required at all. The material is simply too thin to produce a meaningful specimen. Test temperature. This is where UG-84 gets precise. The general rule from UG-84.4 is this: the impact test temperature shall be no warmer than the minimum design metal temperature, the MDMT. But ASME gives you a little relief for very low-strength materials. Table UG-84.4-1 allows the test temperature to be warmer than MDMT by a specified amount, based on minimum specified yield strength. So for a low-strength steel with yield strength 40,000 psi or less, you can test 10 degrees Fahrenheit, 6 degrees Celsius, warmer than the MDMT. For yield strength up to 55,000 psi, 5 degrees Fahrenheit warmer. But for anything stronger than 55,000 psi, you must test at or colder than MDMT. No exceptions. Now, what about subsize specimens? This is where table UG-84.4-2 becomes critical. When you're using a subsize specimen for low-strength material and the specimen width is less than 80% of nominal thickness, the code requires you to test colder than the MDMT. Look at this table. Read that table carefully. The smaller your specimen, the colder you must test. A full-size specimen? Test at MDMT. A 1/4 size specimen at 2.5 mm? You must test 50 degrees Fahrenheit, 28 degrees Celsius, below the MDMT. ASME is compensating for the reduced notch sensitivity of smaller specimens. And one more critical rule from UG-84.4, the test temperature for welds and heat-affected zones shall not be warmer than the test temperature required for the base material. The weld always gets tested at least as cold as the parent metal. Now we get to the critical number. What does your test actually need to achieve? UG-84.5 gives us the acceptance criteria. For table UCS-23 materials with tensile strength less than 95,000 psi, which covers most common carbon and low alloy pressure vessel steels, your impact energy must meet Figure UG-84.5-1. This figure is a graph, and you need to read it correctly. The x-axis is the maximum nominal thickness of your material or weld. The y-axis is the minimum average Charpy absorbed energy in foot-pounds. And there are separate curves for each yield strength level, from 38,000 psi all the way up to 80,000 psi. Let me walk you through reading this graph with a real example. Take SAW 516 grade 70, a very common pressure vessel plate. Yield strength is 38,000 psi. Thickness is 1.5 inches. Go to the x-axis at 1.5 inches. Find the 38,000 psi yield strength curve. Read across to the y-axis. Your minimum average impact energy for 3 specimens is 15 foot-pounds. And this is where the 2/3 rule comes in. The average of the 3 specimens must be 15 foot-pounds. But no single specimen can fall below 2/3 of that average, which is 10 foot-pounds. Both conditions must be met. For high-strength materials with tensile strength 95,000 psi or greater, that's the UHT materials, the criterion switches to lateral expansion measured in mils. That's covered by UHT6. For stainless steel UHA materials, the requirements come from UG-84.1. What happens when results don't meet the criteria? UG-84.6 gives us a structured retest pathway. There are two conditions under which a retest is permitted. Condition 1. The average value is satisfied, but one specimen, just one, fell below 2/3 of the required average. Condition 2. All three specimens have values above 2/3 of the required average, even if the average itself wasn't met. When retest is permitted, you remove 3 additional specimens from the same test coupon. Each of the retest specimens must individually equal or exceed the required average value from UG-84.5, No averaging trick here, every single retest specimen must hit the target. There's also a provision for erratic results caused by a defective specimen or uncertain test procedure. UG-84.6, allows a retest in that case too. And for the high-energy subsize scenario from UG-84.3, if the 75 foot-pound threshold isn't reached, you can retest using full-size specimens. UG-84.7 covers where impact testing data comes from. Option A. Reports or certificates from the material manufacturer showing the material meets UG-84.5 acceptance criteria are acceptable, provided the test specimens comply with UCS-85, UHT5, or UHT81 as applicable. This is your mill test report scenario. The steel mill did the testing, certified it, and you accept those results. Option B. When the material manufacturer has not performed impact testing, the vessel manufacturer can perform the tests themselves to prove suitability. This means you can procure a material that doesn't come with impact test data, and then test it in your own or a third-party laboratory. Flexibility, but responsibility stays with you. UG-84.8 is where fabricators and welding engineers really need to pay attention. It's not just the base metal that needs to be tough. Your welds and heat-affected zones must also pass impact testing when required by UCS-67, UHT-82, or UG-84.4-1. For weld metal specimens, they are taken transverse to the weld axis. The notch is located in the weld metal, perpendicular to the surface. And critically, one face of the specimen must be within 1/16 inch, 1.5 mm, of the material surface. Unless the weld has been post-weld heat-treated, in which case specimens can be taken from any depth. For HAZ specimens, the rules depend on thickness. For material less than 1 inch, 25 mm, thick, extract the specimen at a depth that maximizes the HAZ material at the notch centerline. For material 1 inch or thicker, specimens must come from coupons with their centerlines between 1/4 and 1/2 of the material thickness below the surface. Exactly as shown in Figure UG-84.8-2 of the code. The notch placement at the fusion line is also specified. When the HAZ is approximately perpendicular to the surface, the notch centerline goes at approximately 0.04 inches to 1 mm from the fusion line. When the HAZ is at an angle to the surface, that becomes 0.08 inches to 2 mm. Precision matters here. And when impact testing is required for WPS qualification, the supplementary essential variables of ASME Section X, paragraph QW 250, automatically become essential variables. Any change to those variables means a new PQR. This is a huge point for welding engineers. A change in heat input, preheat, or interpass temperature can invalidate your qualified procedure when impact testing governs. Procedure qualification is one thing, but UG-84.9 takes it further. It requires production impact testing as well. For every vessel, one production test coupon shall be made for each welding procedure used on Category A and B joints. For Category A joints, wherever practicable, that coupon is welded as an extension to the end of an actual production joint, so the welding conditions are identical to the real vessel seam. For Category B joints using a different procedure, the coupon is welded concurrently with, or as close to the start of, production welding, using the same equipment, same position, same procedure. There's a group qualification option. When welding is completed within a 3-month period at one location, the cumulative joint length doesn't exceed 400 feet to 120 meters per procedure. The material is the same spec and grade, and thicknesses don't vary by more than the greater of 1/4 inch or 25%. Then one test coupon can cover a group of vessels. And the consequence of test failure is severe. If the production impact test specimen fails, the welds represented by that coupon are unacceptable. You can reheat, treat and retest, or retest alone, but those welds cannot be accepted in their current state. This is not a soft requirement. Let me bring all of this together for you. UG-84 is triggered by subsection C or D rules, primarily when your vessel MDMT falls below the UCS-66 exemption. The test uses 3 Charpy V-notch specimens, full size 10 by 10 mm for thicknesses 11 mm and above. The test temperature is generally AT or below the MDMT, with very specific adjustments for subsize specimens per table UG-84.4-2. Acceptance is against Figure UG-84.5-1. Average of 3 specimens must meet the curve value, and no single specimen can fall below 2/3 of that. Retest is available under limited conditions. And production impact testing covers every welding procedure on every vessel, with immediate weld rejection if it fails. If you found this video valuable, please hit the like button. It genuinely helps this channel reach more engineers who need this content. Subscribe and hit the bell so you don't miss our next deep dive into ASME Section 8. And leave a comment below. Tell me, what is your MDMT on your current project, and did you need impact testing? Check the description for the link to our full written article on UG-84 at weldfabworld.com. It has every table, every clause reference, and all the code language laid out side by side with practical explanations. We also have the ASME Section 8 Division 1 quiz on our site to test your understanding. Link is below. This is Weld Fab World. Welding till the end. I'll see you in the next one.